Alright, so today we're going to talk about Le Chatelier's principle, something that is incredibly important in chemistry and in particular reaction engineering. And it goes as follows. So if we have a reaction, a reversible reaction, Le Chatelier's principle states that if we apply stress to the chemical system, it is going to shift the equilibrium to the side that relieves that stress, right? So, for example, we have a reaction here. A plus B goes to C reversibly. And let's just take the first case here. So we apply a stress to the system. So there's three different kinds of stresses that we can apply to a system. We can apply heat. We can change the concentration of one of the components. And we can also apply a pressure if it's a gaseous reaction, right? So let's take the first type of stress. So let's say that the, excuse me, that the forward reaction is exothermic, meaning that it's going to give off heat, right? So this will be exothermic, right? So A plus B are going to react to form C and give off a lot of heat. Conversely, C will break down into A plus B if heated, right? So this is going to be endothermic, right? So it's going to absorb heat. So if we have these three components in chemical equilibrium, and we assume that they're, ions, and they're dissolved in solution, and we start to heat this beaker, what's going to happen is it's going to shift to the side, which is going to relieve the stress, right? So that means it's going to shift to the left, right? Because if it were to shift to the right, it would produce more heat. And if it shifts it to the left, it would absorb more heat. So since we're adding heat, it wants to absorb that heat and reduce that stress. Conversely, if we were cooling it off, it would be shifting to the right because it would be giving off heat, trying to resist that change in temperature. All right? So let's get rid of that. So that's the first type. The second type is probably the easiest to think about, right? Changing concentration. So for example here, we take our same beaker and we add B to it, right? So I drew this little beaker here, right? So we're adding B into this, into our equilibrium, our chemical equilibrium system. And so what's going to happen? So since we're adding B, it's going to shift the equilibrium to the right to resist that change in concentration, right? Because it wants to keep the concentration of B the same. And in order to do that, it will shift the equilibrium to the right. So as we add B, it's going to produce more C, right? Conversely, if we started taking B out, started separating it, it would shift to the left, right? Because it wants to produce more B, it wants to keep all the concentrations the same. Okay? So that's the second type. Now the third type, let's assume that these three reactants are in the gas phase, right? And they're in equilibrium, and we have this little piston system here, and we apply a pressure to it. Well, what's going to happen? Well, excuse me, it's going to shift to the side. That's going to relieve the stress. In this case, we're increasing the pressure. So which side would tend to decrease the pressure? Well, it would shift to the right, right? So if the reaction goes to the right, the pressure in the system will decrease, right? Because here we have 2 moles of gas that react to form 1 mole of gas, right? So we're making less, and so therefore the pressure is going to decrease. Conversely, if we had this piston go up and reduce pressure, it's going to shift to the side that would try and keep that pressure the same, right? It doesn't want to change. So what it would do is it would shift the equilibrium to the left, right? You'd see more of A and B as opposed to C, right? So if we shift it to the left, pressure is going to increase. All right, so hopefully this video helped. I tried to keep it as short as possible, but this is definitely something that if you're studying equilibrium reactions, something that you definitely have to practice, and it's really not that hard. So hopefully this video helped, and we will see you all in the next video.